Okay, so still here in Fredericksburg doing these lessons. So let's look at Unit 7, Day 3 today. Unit 7 is a really short unit. So this will be, since it's just about area, we're pretty much done with Unit 7 after today. This will be the last day new material for Unit 7. And then we'll do a practice day, then a review, and then a test. So we're pretty much winding down to the end here for Unit 7. Okay, so on this unit, we've talked about quadrilaterals and triangles. The one shape that we haven't really spent much time on is circles. So it gets its own day because it's special. It gets a whole day to itself. So let's look at circles. Now, this definition is going to sound a little weird, but the geometric definition of a circle is a locus of points in a plane that are a fixed distance from a point, which we call the center of the circle. A circle is named by the symbol that looks like a circle with a point in the middle. So that's how we name it. Or you're more than welcome to write out the name circle and then the point, the center point. But if you're like me, I'm lazy. I just want to draw a circle, put a point in the middle, and then say what it's called. So circle A, the circle over here, has a radius. Well, if we look at all these segments here, a radius is anything that starts in the middle and goes to the edge. So we could say AB is a radius. You could also say AC is your radius. Or you could say AD. Any of those would give you the same distance because you start in the center and you go to the outside. The diameter is the one that goes all the way across where it's in the center. So the diameter would be CD. CD is what goes all the way across. The irrational number pi is defined as the ratio of the circumference, C, we call that capital C, to the diameter D. And kind of cut it off here. So pi is equal to C divided by D. Now, don't get hung up on the word irrational. Irrational is what you probably think your parents are sometimes. They don't make sense. They just go on and on forever and ever and ever. Now, when you get older, you'll find they have sense. But as you're a teenager, you're going to think your parents are irrational. They just go on forever and make no sense. But anyways. So let's look at the formulas for circumference and area of a circle. Now the circumference is like your perimeter of the circle. So you can say that circumference is 2 pi r or pi d. The most commonly used one is this 2 pi r. So this is your most common formula for circumference. For area, it's pi r squared. But I thought pi's are round. Nope, pi r squared. Okay, let's look at this first example. They want us to find the area of circle P in terms of pi. What this means is you do not type, no, do not type pi in the calculator. If you do, I'm taking points off. It says in terms of pi. Don't not. Hang on. Don't type pi. Do not type pi in the calculator. Okay, anyways, let's get past that. They want us to find the area. So area is pi r squared. Now, what is this 16 that they give me? It goes all the way across. This is a diameter. That's not what I need. But a diameter, if you divide, let me back up. To get the radius, all you have to do is divide the diameter by 2. So the radius is 16 divided by 2, which is 8. That's the r we want to use. So I'll put in here pi times 8 squared. Now here's where I said don't type pi in the calculator. I get it. You don't know what 8 squared is. Okay, type 8 squared in. Do not put pi times 8 squared. 8 squared is 64. I'm going to bring the pi down. 64 pi units are centimeters squared. That's our answer. And yes, I'll be able to tell if you type pi in the calculator, because if you typed it in, you would tell me that area is something like either 100 or 200 point something. No, 64 pi centimeters squared. Done. Not even going to show you where the pi button is because I don't want you to use it. Okay, B, find the radius of circle X where C is equal to 24 pi centimeters. Okay, well, let's do the formula for C that has R in it. So 2 pi R. They tell me that C is 24 pi. So I'm going to write that there. Equals 2 pi R. Divide by 2 pi. Over here they cancel. Over here on the left, the pi's cancel. And you're left with 24 divided by 2, which is just 12. So your radius, R, is 12 centimeters. There's your answer. C, ask us to find the radius of circle S in which area is 9 pi centimeters squared. So remember here, area of a circle is pi r squared. They tell us that this area is 9 pi equals pi r squared. If I divide both sides by pi, they cancel. So 9 equals r squared. Now, how do I get rid of the squared? I take the square root. The square root of 9 is 3. That's equal to my radius. So the radius is 3 centimeters. There's that one. Okay, example 2. Says a drum kit contains a drum with a diameter of 10 inches. So let's mark that. D equals 10 inches. Find the area of the top of the drum in terms of pi. Okay, so area is pi r squared. Uh-oh, they give me D. How do I get from diameter to radius? Radius equals diameter divided by 2. So 10 divided by 2 is 5. Okay, so that's what I'll plug in for my R. Pi times 5 squared. Now it says give it in terms of pi, so do not put pi in the calculator. Just put 5 squared. 5 squared is 25. Bring your pi down, and we're in inches. So 25 pi inches squared. Inches squared is your area. So that's just for a plain circle. Hopefully you're thinking, okay, this is easy peasy lemon squeezy. Where's the hard stuff at? Oh, that's what we're going to get to now. Okay. So the area of a sector is a fraction of the circle containing the sector. The sector of a circle is determined by the measure of the central angle of the circle. So let's put this in a formal definition. A sector is a region bound by 2 radii of the circle and their intercepted arc. So think of it like a slice of pizza. It's a slice of the pizza. That's a sector. To find the area is similar to a normal circle, pi r squared. But do I want the whole circle? No, I only want m degrees. So m over, how many total degrees are in a circle? 360. So pi r squared times m over 360. That's the fraction of the circle I want, m over 360. Just remember that. It's the area of the circle times the fraction I want. So they say, find the area of each sector. Give your answer in terms of pi. So sector MPN. Area is pi r squared times the fraction I want, m over 360. So pi times 3 squared. The fraction I want is 80 degrees out of a total of 360. So now, the only thing I want you to put in your calculator is this. Ignore the pi. The pi will just appear in our final answer. We'll just carry it down. So if we put that into our calculator, we'll find that that gives us 2 Then we just bring the pi down. So 2 pi inches squared. That's our area. 2 pi inches squared. Okay, next one. Find the area of sector EFG. So, formula for area of a circle is pi r squared, but then I only want m degrees out of 360. So pi, our r is 6 squared, times 120 over 360. Again, we want it in terms of pi. So if you put anything in the calculator, it only needs to be this part. So area is going to equal 12 pi centimeters squared. So that's a sector. Hopefully it's not too complicated. We just only want a piece of the circle. So I only do a piece of the area. So in the same way that the area of a sector is a part of the area of a circle, the length of an arc is a part of the circumference of a circle. So arc length is the distance along an arc measured in linear units. So remember how circumference was like our perimeter? This is only a piece of the perimeter. That's all we're interested in, just a piece of the perimeter. So we're going to use our formula for circumference, 2 pi r, but I only want a piece of it. So m over 360 will give me just that piece. So let's look at example 3. Find each arc length. Give your answer in terms of pi. Okay, so here they say arc CD. So the length is going to be 2 pi r times m over 360. It's going to be 2 pi. The radius is 10. Our angle is 90 over 360. Again, if you're using your calculator, do not put pi in. Put everything but the pi. 2 times 10 times 90 over 360. It's going to give you 5 pi for your length, arc length, and we're going to be in feet. So the arc length is 5 pi feet. Okay, here they don't give us a picture. They give it to us in words. An arc with a measure of 35 degrees. There's our M. And a circle with a radius of 3 inches. There's our R. So L equals 2 pi R times M over 360. It's going to be 2 pi, R is 3, M is 35 over 360. Again, if you put anything in the calculator, do just the numbers. Don't put your pi in there. Now this one, it'll give you a fraction. So let's leave that as a fraction. 7/12. Bring our pi down. And then we're in inches, since it's arc length. 7/12 pi inches. That's the length of that arc. Okay, so that's day 3. That's the last of the new material for Unit 7. We're going to do a practice day next, then a review, then a test. So until then, stay tuned for the guided practice.